The panel we have here before you is on a topic related to our overall, how do we cooperate both from agency to agency and across industry as well. So back in January of early this year, we released an update to the overall global exploration roadmap. And in there, we kind of gave the updated perspective of the agencies around the world of how we may cooperate together and where the potential opportunities lie. And one of those opportunities is also the reliance on commercial industry and how they will play a part in that critical global exploration roadmap. So with me today, we have an esteemed panel of folks. Dr. David Parker, who's been working in both the public and private sector since 1990. He's the former chief executive of the UK Space Agency, chair of ESA's Human Spaceflight, Microgravity and Exploration Program Board, and since 2016 has been the director of Human and Robotic Exploration at ESA, based at ESTEC in the Netherlands. Next to him is Pierre Jean. Pierre started with the Canadian Space Agency in 1998 to work on CSA's Space Station Program Team as Manager of Safety and Mission Assurance, and then Manager of Logistics and Sustainable Engineering. In January of 2009, Pierre was promoted to CSA Program Manager. Pierre assumed the role of Director, Space Exploration Strategic Planning in January of 2016 and oversees planning activities for CSA's planetary exploration, space astronomy, and human spaceflight programs, including Gateway. Next to him, Jeff Mamber. He serves as the CEO of NanoRacks since 2009, growing the company into the first commercial space station company with customers. Before NanoRacks, Jeff was the only American to officially work for the Russian space program. He served as a managing director of Energia USA, carried over the first commercial contract between NASA and the Soviet Union, and served as CEO of MirCorp, which leased the Russian space station. Jeff later represented Russian space organizations with the initial ISS contracts were negotiated. And in 2012, Jeff was awarded the NASA Exceptional Public Achievement Medal as well. Next to him, John Roth. John is the Vice President of Strategic and Business Development at SNC's Space Systems business line that spans civil, commercial, and DoD markets. He's been leading the international partnerships and outreach activities related to LEO and commercial explorations at Sierra Nevada Corporation. And then next to my left, Dan Hendricks. Dan Hendricks serves as the Vice President of Business Development for Astrobotics, a Pittsburgh-based lunar logistics company, and provides end-to-end payload delivery services to the moon. So, as you see, we have a broad spectrum of participation here from both agencies and industry perspectives. And I'll go into a little bit of an overview of where we were on the global exploration roadmap. So, it first was released back in 2011. We are on the third revision of it. It's signed by or agreed to by 14 nations. It's a non-binding kind of strategy document, though. And we talk about their sustainable principles, the importance of the ISS and low Earth orbit, the extension of that importance into the moon, and then Mars as our overall horizon goal. So with that, I'm going to give you a little bit of perspective from NASA. And one of the things that we always try to balance is explore and develop. So how do we balance the advancement of human spaceflight activities and do the things that really don't have the commercial return but are critically important to the advancement of exploration and science, while at the same time doing things in such a way to develop space and develop the overall leadership strategy of the U.S. government in that exploration strategy as well. So we always have this dichotomy of activities of both exploration and developing that's incredibly important. That's captured in our most recent Space Policy Directive 1. With this incoming administration, updated that, and also renewed our emphasis on the kind of stepping stone or incremental approach with the moon being that first destination for us. On NASA, we do govern about, with our own set of strategic principles. We have about 8 of them, everything from fiscal realism to understanding how we can have a continuation of human spaceflight activities. We actually leverage from the scientific discoveries and the technology advances that we have. And then we count on the gradual buildup of capabilities that enable more and more challenging exploration missions over time. So in the coming decade here, there's a whole host of activities that NASA is doing under our exploration campaign. Everything that from our development of SLS and Orion to the actual first elements of the Gateway, and then actually moving into commercial landed services for lunar landers, and eventually even building the capabilities for human landing return. So there's an exciting portfolio of work at NASA that all is in line and actually in cooperation with our international and commercial partners. One of the aspects of that is Gateway. So Gateway is our next kind of platform of infrastructure that we are intending to put in orbit around the moon. It will provide a whole host of features, everything from the critical infrastructure to enable return and trips to the surface of the moon, to actually serving as a port where we can build spaceships up and depart and do things from Mars. But in addition to that, it'll extend our international partnerships and cooperation in cislunar space. And what you see here is kind of a depiction of the potential contributions from NASA and our international partners over the coming decade as we look at enabling a gateway for the future. With that, we've also released international operation interoperability standards that have been published out there to help enable our global community to actually work together. With those, we have the 8 standards or 7 standards that are listed there. There's actually 2 more standards coming soon. And we're using this to enable and expand the ability for cooperation between industry and our international partners as well. There's a whole set of activities that NASA has that corresponds to that chart that I showed. Everything from leading from our first commercial crew flights coming up very soon, to the first flight of SLS and Orion, to the actual deployment of the first element of the power propulsion element, our desire to land a mid-sized lander also by 2022, and then actually enable that entire sequence of the buildup of the gateway. So there's an incredible kind of decade of activity that's in front of us, and NASA is looking forward to how we continue to cooperate between our US industry and our global partners that we've had, and expand on those partnerships. So with that, I'll turn it over to David, and he'll give a set of opening remarks as well.
Great, thank you very much. Good morning, everyone. I hope the mic is working. Yep, we're on live. Yeah, okay. So I have to start with an apology, which is I actually have hot-footed down here this morning from a parallel meeting going on in the building here. So after my presentation, I'm unfortunately going to have to run away after listening to the other presentation. So I apologize for that, but maybe after you've heard my presentation, you think it's a good thing I'm running away. So we'll see how it goes. My purpose here today is to give a little bit of flavor of Europe's involvement in space exploration, building on the partnership with the International Space Station, long-running partnership. We celebrated 10 years this year of the Columbus Laboratory aboard the ISS. Alexander Gerst, a European astronaut who happens to have a German passport, is up there at the moment undertaking a large program of scientific activities and will in due course take command of the space station. So the partnership with the US and all of the international partners on the space station is a solid part and basis of what we're doing. I always start with a reminder of what we mean by exploration in the European context. It's a point I always have to make that ESA's space exploration activities, human and robotic, are a relatively small part of ESA's overall activities. We're a full-service space agency spending about €5.75 billion a year, some $6.5–7 billion if you like, and only about 10% of that is associated with space exploration. It's not the most important activity that ESA does. The activities relating to Earth observation are much larger. The launcher activities, the separate space science program, and various other activities to satellite navigation and so on. But the exploration program has this unique element of reaching out into the solar system and bringing back new knowledge, scientific discoveries, preparing us to live and work in places in deep space. And I always go back, the Global Exploration Roadmap is building on the original Global Exploration Strategy Framework document of 2007. And I always urge people to go back and read that document. It's still on the NASA website. Most of, if not everything that's in that document written all those years ago is still valid. And for us, the international partnerships are a really key element of exploration. They're needed, they enable exploration, but they also are a benefit back to humanity of the sustained international partnerships. But exploration is not only about science. Exploration without science is just tourism. But exploration also has an economic perspective from our point of view in terms of challenging the development of new technologies which have a value back here on Earth. So I take the example, you and I use 120 litres of water a day. The astronauts on the station are less than 5 litres of water a day. So that's why we're developing technologies like the Advanced Crew Life Support System that will launch in a couple of months to the station, which is trying to drive down recycle even more to the point where we have a sustainable possibility of living, working further out in space. So it's an example where the technology is needed for exploration, but that kind of efficient recycling technology is supporting sustainable economy back here on Earth by transferring that technology. And then exploration, and particularly both human exploration, but also robotic exploration, has the unique possibility to inspire. And this is kind of STEM day here at the conference, so there's very relevant elements of the strategy. All of this was defined in an exploration strategy in ESA in 2014, approved by our 22 member states. And that has enabled us to undertake and integrate the different exploration activities, human and robotic, in what we're doing right now. Our program is approved for periods of 3 years at a time. The first first period of our exploration program was approved at the end of 2016, and the next decision point is at the end of 2019. So already we are continuing to live and work aboard the space station. We have a world-class program of fundamental science. But in preparing to go deeper into space, we are building the first 2 European service modules for the Orion spacecraft, or spaceship as I like to call it. And actually, we just received authority to start work on the 3rd of the service modules that we deliver to NASA as a contribution to our cooperation. Mars is an end goal of not an end goal, but a horizon goal for human exploration. And understanding Mars as a complex planet, its history, and preparing for human exploration is being undertaken today through our ExoMars program. So the ExoMars orbiter is the largest spacecraft in orbit around Mars right now, looking for trace gases, but also acting as a telecommunications relay. It's demonstrated telecoms relay for NASA's rovers already. But the second element will be the ExoMars 2020 rover that will be the first to explore Mars in 3 dimensions, going below the surface with radar and with a drill. We're also building technologies for lunar exploration, for precision landing, and understanding the presence of volatiles, so a contribution in international cooperation with the Russian partner, Roscosmos. And we're planning the future missions and opportunities to take us forward. And we're bringing all of these ideas together in a kind of campaign of exploration for the next 10 years. So my responsibility includes the robotic exploration as well as the human, and we balance human and robotic, and also the interaction between human and robotic. And it's not about Moon versus Mars, it's about a coherent strategy that draw these elements together to deliver science and sustain by a technology development program. So we see ourselves as undertaking these 4 campaigns, and this has been well discussed with our member states. Now, Jason's already shown the picture of the gateway. So we have an aspiration supported so far by Phase AB1 studies, and there's significant investments already underway to make potential contributions to the gateway beyond what we're already doing with the European service modules. 2 elements are under consideration: a potential international habitation module and something called ESSPRI, which stands for European System Providing Resources, Infrastructure and Telecommunications. So it's refueling the gateway, it's providing advanced telecoms function, a science airlock to get scientific payloads, instrumentation outside of the gateway. And also based on a long heritage in developing docking systems that could also be elements relating to docking technology. Relating to lunar surface exploration, as I hinted, we're already in the first phase of preliminary design review phase of a precision landing system, a kind of Google smart car for landers, to get us down to interesting areas in the south polar regions of the Moon and drill below the surface and extract samples in the search for volatiles. So there's a particular speciality, if you like, of Europe is drilling. We did that at the Rosetta Comet with Philae. We're doing that with ExoMars, and we intend to do it with Lunar Resource Lander. Our European commercial space industry has ideas to do things relating to exploration, and so we have working with a European company on an idea for a lunar telecommunications and transportation system called Lunar Pathfinder that would lead to eventually a constellation of telecom satellites of the Moon. We had a really exciting workshop a few weeks ago, bringing more than 250 people together to talk about in-situ resource utilization at the moon. And we're also exploring how commercial partnerships could enable that mission. And this is all stepping towards a goal to integrate the human and robotic exploration by a vehicle that will go down to the surface of the moon, an advanced rover to undertake exploration into the deep, dark places on the moon, bring interesting samples back up with an ascent vehicle that would close the loop, as it were, and return to the gateway. And that's why we've been investing a lot over the years in research on telerobotics, demonstrating control of robots on the surface of the Earth, control from the space station as an analog to doing this at the moon and then doing it at Mars in due course. So it's a vision for how we would combine investments and work relating to the gateway to a robotic program that would prepare for a sustainable human return to the moon. I'm not going to talk much about the Mars exploration any further. That's an important future next step. But in summary, those are our ideas that would bring together international partnerships, commercial partnerships, and human and robotic exploration in Europe. Thank you very much. So. What I would like to do, if I may, is to just cue up a little video. I spent, I guess, about a quarter of an hour explaining that, and maybe in 1 minute, 30 seconds, we'll draw together what I've said in terms of a video presentation of Europe's exploration program. So cue the video, please. Thank you.
Thanks, David.
Oops, gotta go back. Okay. Good morning, everybody. Just a little bit of a warning. I got a bit of a cold, so if I cough, you're either going to have your eardrums punctured or you're going to wake up, one of the two. So it's my pleasure to be here today to speak to you a little bit about how Canada sees itself in future global collaboration on deep space exploration. I think it's fair to say that the Canadian space program is probably one of the real true collaborators and participants in international programs. I looked at a list of all of our programs, and there was essentially only one that was Canadian in terms of exploration, and that was an astronomy mission. But everything else has been done internationally with various partners, ESA and NASA, both of them, India and other countries. So we don't see participation on an international scale as a challenge, as a threat. It certainly is a real opportunity. And because we're not the large ESA or NASA, we don't have the same resources to bear. We have to look for opportunities on where Canada can bring its unique skills and talents to bear on the challenges that face the international community in various missions, as you see in ISS and others. So from that respect, as I said, we're very internationally focused. Global collaboration is a big objective for us, and as a result, we've been part of that International Space Exploration Coordination Group effectively since its inception. Participated in the production of the 3 global exploration roadmaps, of which Jason mentioned earlier. The last one, the third one, came out in January. One of the things that the roadmap talks about, though, is not forgetting where you come from. And I think my first chart here is really just to highlight the activities that take place on the International Space Station. It's the ISSRD, and I'll talk a little bit more detail about our ISS participation and the importance of that. But also, I just want to make a little side point that we do have participation in robotic missions, planetary missions, and space astronomy missions, and that like. But today, I just wanted to focus mostly on the human spaceflight. So why is it important that the ISS? I think the most important thing about ISS right now is that it's a great opportunity to develop those technologies and to learn from our mistakes and to learn from the experience that we've gained over decades of operation now. The MSS, Canada's contribution to the ISS, was launched in 2001, first element. So we've effectively been on orbit for 17 years, actively operating in the external, very difficult environment of space. So we've learned a few things. We've learned that some of the decisions, some of the assumptions we had in the early 90s about lubrication, the qualities of lubrication, dry lube versus wet lube, we've learned firsthand on the ISS that our decision to go to dry lube in the 90s may not have been the right decision, at least as it relates to our system. And we've had operations in the meantime to actually go back and have the crew members lubricate the joints, critical areas of the joints, and we've seen dramatic performance increases because of that. Simple, putting grease on a stick and dabbing it in the right area like you would do anywhere else in your bicycle or whatever. So we've seen those types of benefits. We've also seen that when we started off on the mobile servicing system, this was a system that was effectively to be operated uniquely by astronauts from a robotics workstation in the ISS. It doesn't happen anymore. Through the course of the evolution, we've taken some of these basic things that we thought we can't go any further than this, and we've extended well beyond that. We had rules at one time that if one joint failed, the whole arm had to fail. Well, that seemed kind of ridiculous. We could have continued the mission with 3 joints or 4 joints. So we've implemented continual software changes to give the control system of the robotic arm greater functionality. And we've also started applying a lot of modifications with respect to how we operate it from an autonomous capability. So now virtually all operations are commanded from the ground and effectively done all from the ground with very little direct crew intervention except for visiting vehicles. And then ultimately that will disappear as well as we learn and grow our experience and our confidence in systems. One of the things we noticed as well over the decade that we've been operating, almost the 2 decades actually, is that operations have just gone up and up and up. We had last year was an unprecedented year in terms of operations. I think we sent 100,000 robotic commands to the station. And so what we need to figure out is how do we reduce the overhead on that, and how can we leverage our experience here going forward into a development of robotic arms into the future. So we're going to use this great chart because this is what we're talking about as a next great step. Low Earth orbit, the importance and the value of low Earth orbit will never disappear. We need that critical infrastructure, whether it's the ISS or future space stations, to continue technology development, to continue research on life science and the challenges that face astronauts in deep space or in space, and then beyond that in deep space. So that goes without saying, but we're growing and we're expanding our vision, and as part of the global exploration roadmap with the real horizon objective being Mars, the Gateway was the next step where we could take that next step with good confidence, continue to develop technologies and experience such that, well, we can use the Gateway as a stepping point to the moon, and ultimately as a staging point for missions to Mars. As you would expect, Canada has a history in robotic arms. We built the robotic arm for the shuttle in the 80s, or in the 70s for the 80s. We've got the robotic arms on the ISS now, and they're not the same. And what we envisage for what we call DSXR, the Deep Space Exploration Robotic Arm, the next Canadarm3, if you want to call it that, is to take all the lessons from the past and the technologies of today and build an arm that's going to, is going to be well beyond the capabilities of what we have today. It's not about size, and what I would say in a sense is that when we look forward at the next robotic arm, it will be self-repairable. So effectively, it won't need EVA to go out and replace a joint or replace an appendage or something like that. It will be done by the arm itself, and then components of the arm can be passed through the airlock into the internal volume and either repaired by a crew member or prepared and returned back to Earth for more detailed repair. So these pictures here just show the basics of robotics. There's berthing, visiting vehicle capture. These are all on the top right. You see the basically the small dexterous arm effectively removing the end, the latching end effector and the end joints on the large arm as a part of a maintenance operation. And of course, when there are contingency missions, contingency EVAs on the gateway, the arm will obviously be there to support those types of things. One of the areas, it's not a great chart, but I just pulled it together, and one of the areas that we're really looking at now, can we build a robotic arm that can service the external areas of the gateway, and at the same time use the small dexterous arm, which will service the large arm, but then pass it in through since it can be passed into the airlock for its own repair, can we pass it into the airlock and then use it as an IVA, as a robot inside the volume when the gateway isn't manned by astronauts? So rather than building another robot or having another system, we could repurpose and reuse and adapt our external robotics to work on the internal volume. So only thoughts today, but these are thoughts that need to be explored, and we're doing studies on that to see what the potential is. And of course, it depends on how the internal volumes are built. But that's a really important area where we can see an expansion, and again, all there to support and make the life of the crew more effective in their day-to-day world. At the same time, it's not on this chart, but science has become an extremely important reason or rationale for an arm. The astronauts will be there 30 days, 45 days a year, but we don't want to stop doing science, and we want to be able to service science, payloads, and all that, both externally and potentially even internally. So it's an operation that we will be looking at. The other thing that we're also very interested in, not that we only look at robotics, is we took the technologies that you find in robotics and we said, well, how does that, and it really parallels very closely with rovers and that type of mobility technology. You need vision systems, you need control systems, you need all these sort of type things. So since the early 2000s, this sort of just shows a stepwise sort of progression in some of our, it's a little bit cryptic, mind you, but it's really just there for color while I talk. It's really just there to show that we've been progressively exploring and investigating rovers. We've invested a lot of money in the 2008 to 2012 period. When there was an economic stimulus, we managed to snag a few $100 million from our government and applied it in part to looking at rover technologies. And we're going to have a gateway, so we need a purpose for that gateway, and the lunar surface is that next purpose. And so we're working very closely with ESA, JAXA, and of course NASA, as we look at this Heracles mission, which is the opportunity to land a precursor rover onto the lunar surface, conduct science, bring back samples, and so we're looking at that. We always have to be one step ahead of the game. We're trying to design the gateway, but at the same time we have to find purposes and the future for that gateway. With that, the only other thing I would mention is that, so I've talked a little bit about robotics, rovers. I think the other area that Canada sees as very significant in the future of space exploration is the medical or health, medical technologies, health realm, if you will. I mean, astronauts going deeper into space face longer and deeper challenges, and so we have a life science program that's running on the ISS, and many of our partners do as well, and we work together on these types of things. But we're really looking now and today and investing money to find out what are those medical technologies that we could leverage forward to the gateway, possibly to the lunar surface, that would have benefits on Earth. Of course, that's the great way to spin it, because we are a country, the large country, a very remote country in some places. And so there's a real good analog. By demonstrating things in space, we can apply them on Earth as well. So we see that as a real opportunity to contribute in the future. So as we go forward, that's an area you might see more investment in from a Canada perspective. Thank you very much, and I'll let my next speaker have the mic.
Good, thank you.
Thanks, Peter.
Yeah. Thank you, and you did fine. Yeah, you didn't cough, right? You did good. Thank you, and there may be some logic, actually, to this panel, the progression, because with Jason involved, of course, there's logic. And so we heard from NASA, we've heard from the agencies, ESA and the Canadian Space Agency, and maybe it's appropriate that NanoRacks goes first now on the private sector, because for 8 years, we've been working on the International Space Station. And as you may know, we're probably the largest commercial user of the International Space Station on behalf of our customers. And we now enjoy having a customer base in 32 nations. And we just hit a 700 payload milestone, which in terms of American baseball is significant as we get into the Babe Ruths and the Henry Aaron numbers. And so what I would like to do this morning is focus a little bit from our perspective that one of the legacies, you talk about what we learned from the ISS, and one of the legacies that I've always felt is most important on the ISS is how does the private sector and the governmental organizations work together. That to me is one of the lessons that we have at NanoRacks. And so at NanoRacks right now, we are, of course, as I said, working on the space station, but we're looking forward through the next steps and other NASA programs, and we're hard at work on commercial space stations. We call them outposts. And we're looking at converting upper stages of launch vehicles as a cost-efficient way to develop commercial platforms. And as we've heard from everybody, so far, the ISS is that test bed. And what we're learning at ISS, both at NanoRacks, what we're learning on customer development, working with agencies, what works, what has a marketplace, how do you survive as a commercial in-space operations company? These are all lessons that we're taking from the ISS. I mentioned our Space Outpost program, Independence 1. We're working with ULA, we're working with MDA, and we're very appreciative for the Canadian heritage in robotics. And we've shown that you can convert an upper stage, spent upper stage fuel tank using robotics that are on Mars today, the MDA robotics, and you do not need a human presence. And this is pretty interesting, and this is pretty surprising. And as I said, what I really wanted to focus on in my brief presentation is the public-private partnerships. We have two major projects going on now. As you may know, at NanoRacks, we started 8 years ago, and we've built up. We started with little nano labs, which at the time, NanoRacks was the first company to own and operate its own, operate and market its own hardware on the space station. We started with little nano labs that we chose not to patent, so that there would be an ecosystem. And I remember 8 years ago that Jason was very, very happy about that. And I don't know if I regret it, because now we have all sorts of competition. And, but it's what we wanted. We wanted to have an ecosystem. And so we've tried to keep everything open source. And we've grown up from the nano labs. We've deployed over 230 satellites from the space station. And we're appreciative that we have ESA, NASA, and the Canadian Space Agency as customers. And the two biggest projects that we have now, one is the Bishop Airlock. The Bishop Airlock is a very, very large project, and very large especially for NanoRacks. We've decided to introduce risk mitigation and sort of double down on the airlock, the resources on the station. Currently, everybody uses the Japanese Kibo airlock, which is beautiful, and we're very appreciative of it. And we've decided that there's a market, sustainable market, to have an airlock that's about 5 times larger than the JAXA airlock. And so we went forward with no NASA funding, no guarantee that there would be customers. Our partners are Boeing and Thales Alenia, and so we're drawing on the expertise that exists in those two fine companies. And we approached NASA and said, would you give us permission? Would you give us permission to have some real estate? So when you look at the partnership, it's really the NASA, the public sector, contributing the real estate, the given node, which of course the taxpayer funded. We are relying on NASA for basic operations and some station resources. NASA may or may not be a customer. It's to be determined, and we're hopeful that NASA indeed will be a customer. And we get subsidized transportation, which is necessary. Everybody who works on the station through our Space Act agreement with NASA gets a subsidized transportation to and from the station. On the private sector side, we contribute the concept, we contribute the funding, and we develop the customer base. And we hope that we bring market efficiencies, no offense to anybody on this panel. So, and it's working. It's worked. We've had, I think, 3 or 4 Space Act agreements with NASA, each one with various degrees of complexity. And we've learned, as we're all saying here, we learn each step of the way. And how should we treat NASA as a customer? What can NASA do? How soon can NASA be a customer? What limitations? NASA had to learn early on 2 fundamental principles. One, it's okay to fail safely. And the second is that if they're a customer, they don't get to tell us exactly what to do in the terms of the hardware design. At times we reach out to NASA and we're very grateful for their help in design, but if it's commercial, we sort of live and die on our own. And so as we look to the next stages, like Independence 1, well, to us at NanoRacks, we're pretty much laying the foundation for how the partnership should be. There's not that much of a change. I mean, we think that one of the legacies of the ISS is that even as the hardware, the programs get bigger, the fundamental aspects of the public-private partnership, whether it's in LEO, whether it's in cislunar, or whether it's in deep space, we're figuring that out now. And that's very, very exciting from the vantage point of us in the commercial sector. It would be impossible to have envisioned 10 years ago to have the relationship that NanoRacks has today with NASA, where the lines are becoming clear, what we have to contribute in terms of funding, what NASA expects from us, what determines success, what determines failure. And I have to say that this is a fascinating time because folks in the space agencies, whether it's NASA, ESA, and Canadian Space Agency, and JAXA, and to a limited degree Roscosmos, but also Roscosmos, are struggling to find out how do they behave in this era of greater commercialization. And we too in the private sector are struggling, and there is no one answer, which makes it so interesting. There is no yet right answer. But we feel that the public-private partnerships we at NanoRacks have with NASA are paving the way to showing the right way to go forward. And let me say also, we've just announced we're opening a European office in Italy, and we're beginning to engage with the European Space Agency in a correct European manner. And we look forward to taking the lessons that we've learned as they apply for the European theater and learning what ESA wishes to do on commercialization. So in my view, the good news is deep space won't be too radically different from marketplace development. And from my point of view, there's 5 or 6 requirements that we need to have true private sector participation in, as we move beyond LEO. The first is policy. And there's an adjective, I think it's an adjective, right? Set policy. I cannot explain to you how important it has been that we've had extraordinary bipartisan support for the International Space Station for more than a decade. There is no way that NanoRacks could have existed, grown with private sector investment, with revenue from customers, without having set policy. Okay, and so it's extremely important that there's policy in place that lays out what would be the role, the behavior, the sets, the terms and conditions for the private sector moving forward as we leave LEO. And then, so that way, if you know the policy and you know what the government's contributing, you know what is possible for you to contribute in the private sector. And if you know what's possible for you to contribute, then you can begin the necessary, what is the marketplace, and what is the cost of developing this technology? Sometimes people still in the government ask us at NanoRacks, how do we determine pricing? And it's like, well, you figure out what it costs to develop a certain piece of hardware. You figure out you want 5-6 years return on investment, and you then go out in the marketplace. And sometimes we've been right, sometimes we've been wrong. On our external platform, which sits outside this station, it was built, manufactured by Airbus, our initial pricing was wrong. We were too high because we were disrupting ourselves with the CubeSat deployments from the station. And we had to lower the pricing of the external platform to allow people, to encourage organizations and customers to use the external platform instead of building a CubeSat to test certain hardware. So you don't always get it right. It's an art. It's not a science. And then so once you develop the technology, you know the cost and the condition, and you introduce it into the marketplace, develop a pipeline, and now I want to leave you with is for me the most important thing. For I don't know how many years, 15, 20 years, I've been arguing in Washington, and I'm stubborn, I'm not gonna give it up, that government as a customer is commercial. Government as customer is commercial. Just as when the government employees here flew to this event, they went on an airline. Airline was built by Airbus or Boeing. The tickets were sold by a commercial provider. It did not matter that they were government employees. They may have negotiated better pricing than when NanoRacks flew here. Okay, but the basic terms and conditions are the same. And so we're very pleased and appreciative that among our commercial customers includes ESA, European Union Commission, DLR, NASA, along with biopharmaceutical companies, Planet Labs and others, Aspira. And so for us, government, if it's laid out where we're investing the hardware and we're taking the risk, and you don't necessarily have the government as a customer when you propose the project. And in fact, I just assumed something. You're proposing the project and you're going into the marketplace. We need the government's permission, whether it's Deep Space Gateway or whether it's Space Station or beyond. But if it's private capital at risk and it's operating in basic terms and conditions, the public-private partnership allows for government as customer. And that to me, from a NanoRacks perspective, from my perspective over my career, the most important thing as we look to go beyond LEO is to make sure that we have the relationship articulated and we begin to have that discussion now, which we are, on what is the right public-private partnership. And I recognize that the right public-private partnership in the United States may not be, in fact, is not right for the European and the Canadian. Each culture is different. Each society has its own relationships with the private sector. But now is the time to begin that dialogue and understand the right way to have public and have private sector participation as we move into deep space. And I think that's it. Thank you.
Good morning, everybody. When Jason asked us to introduce our companies on the panel, kind of the guidance that we got was to let people know what areas of interest we have in exploration, how our company fits into the exploration environment, and then talk about our experience in public-private partnerships and global collaboration. The companies here were chosen because we all are interested in international cooperation. We've been doing international cooperation, and that's still kind of a little bit unique in the space industry. We tend to be stovepiped in our space programs, where the U.S. programs are doing U.S. things, European programs are doing European things, and sometimes the agencies collaborate at a NASA to ESA level. But what we're starting to see as we're moving into this whole public-private partnership arena is there's got to be a lot more collaboration at the company-to-company level and even company-to-agency level. So things are really starting to shift. It's a very exciting time in the industry right now. I'd like to start with saying our company's been in business for more than 50 years. Sometimes Sierra Nevada's thrown into the startup company pot, but really we've been around for 50 years. We've been doing things in space for 25 years. So to give you an idea of kind of some of the things that we do, since I'm at an ISSRD conference, I have to talk about ISS things. We do build payloads for the International Space Station. Just in the last several months, we've launched the Advanced Plant Habitat, which is a follow-on to the Veggie system that we've been building on the station. And we also launched the zero-G mass measurement device. And we're actually going through a process now of measuring the mass of mice on the International Space Station. So in zero-G, you can imagine it's not as easy as putting a scale on board and sticking something on a scale. You have to figure out how to do a mass measurement in zero gravity. So certainly our interest in low Earth orbit has been around for a long time. As most of you know, hopefully everybody, we're also building the Dream Chaser space vehicle, which is going to be a cargo transport system to the International Space Station. And we hope to work with Jeff's company and many others for getting more science experiments up to the space station. And more importantly, to be able to bring those science experiments now back to Earth at very low G reentry, so there's not a lot of stress on the payloads, bring them to a runway and get immediate access to the payloads. So we're really hoping the Dream Chaser adds a whole new dimension to the R&D activities going on in the station, because when the station was originally developed, it was mostly about return capability and getting science back to Earth and seeing what the results of that science are. So we hope that the Dream Chaser really starts filling a gap that was left when the shuttle was retired. In terms of things beyond low Earth orbit, our company's been a trusted supplier to JPL for really more than 20 years. I think we've been supporting missions. We've been to 7 planets. We're radical believers that Pluto is a planet still, so we've been to 7 planets. And we've done now 13 missions to Mars we've been part of. With the Mars Insight, we're part of Mars 2020. That will be our 14th mission to Mars. So low Earth orbit's of interest, but certainly we've been involved in exploration programs for a long time. And our company is really excited about where NASA is headed now in lunar activities and eventually Mars activities. It's something that our owners are super excited about. We're a privately owned company. A husband and wife own our company and actually are the day-to-day operators of our company. So we're kind of unique at the size of company that we are, that we're privately owned. And they are personally very excited about space. They originally were born and grew up in Turkey, and they can remember looking at the U.S. space program when they were in Turkey growing up and going through school, and how exciting it was, and they kind of pinch themselves every day that they're now over here in the U.S. are running a company that's at the leading edge of some of the things that are going on in space exploration. So it's a real joy for our company to be part of this. Dream Chaser, I think everybody's familiar with. If not, I should fire my marketing department, because we spend a lot of money in sponsoring things like this to make sure everybody knows what Dream Chaser is. It not only is going to be hopefully a workhorse for NASA in getting cargo up and science down, but also we're looking at a lot of international partnerships to make use of our vehicle for other applications, free-flying science missions, servicing type missions, maybe debris removal missions. There's a whole range of things that we can do in low Earth orbit with Dream Chaser, and that's part of the reason why we started an activity a number of years ago to reach out to international partners, because this vehicle was developed as a public-private partnership, and from the get-go, NASA said we don't want to be the only operator of Dream Chaser. The whole idea is that we will be an anchor tenant, and we want all our providers to go out and find other applications for the vehicle to reduce the overall cost to everybody, reduce the cost to NASA, reduce the cost to international partners. The other thing we're currently engaged with is in Jason's program, which is a Deep Space Gateway. We're one of the contractors that are doing an architecture concept for the gateway. We also were one of the contractors for the first element, which is the power and propulsion element, and we completed our study on that element as well. That's something that we're deeply interested in moving forward with is lunar exploration. Talk about international relationships. I purposefully use the word aggressively pursued international relationships because it's not something you fall into or do haphazard. It can be difficult to become an international player. We started signing agreements with international agencies back in 2013. So for more than 5 years, we've kind of nurtured these relationships. We started with the German Aerospace Center, DLR. That moved over to the European Space Agency. Then we got JAXA to come on board. And finally, the Canadian Space Agency. We recently signed a partnership agreement as well. In many cases, this is the first time that a private company has signed a memorandum of agreement with a space agency, an international space agency. Almost everything in the past has been agency to agency kind of collaboration. So we sort of went through some new ground there. And that includes going through new ground with the United States State Department and the ITAR regulations, and how do we have a commercial company interacting directly with the International Space Agency. So Jeff has laid a lot of new groundwork and found out a lot of lessons learned. We've gone through the same thing on some of the things that we're trying to do and laying new groundwork. And these agreements are all about collaboration. So they're not about us selling something to an international partner. I think the days of U.S. saying, well, we see the international world as just a market, and we can take our products and we can sell our products to the international market. That's still viable in a lot of cases, but I think we're trying to go much more beyond that. Let's find a win-win situation where we're actually collaborating with these international agencies, that we're utilizing technologies that they develop in our products. We don't have a patent on intellectual property for space. There's a lot of smart people in the world, and these countries have been doing space programs for many years, and they have lessons learned that are way beyond what we have been able to do in private sector. So we're taking advantage of that. We're using DLR technologies, ESA technologies. We're working with the companies that are involved in the programs for those agencies. We've engaged directly with more than 20 international companies. We have international partners on Dream Chaser. We have partners from Canada that are supplying critical subsystems to our vehicle. We have partners from European countries that are providing critical subsystems. So it's not just us selling things to those nations, it's us taking advantage of the technologies they have and helping to move their industries forward as well. The whole idea here is let's move everybody forward in space. Nobody's going to have a total capability of doing everything we want to do in space by themselves. The ambitions are too big, the budgets required are too big, so we got to figure out how we're going to do this as a global team. One of the things we're really interested in is the partnership we have with the United Nations Office of Outer Space Affairs. We signed an agreement with them in order to do a joint mission using our Dream Chaser vehicle and really targeting undeveloped countries and giving them an opportunity to fly things in space when they've never been able to develop payloads for space. So that's another exciting partnership that we've got going on. We think that moving forward, we're going to have to take the model of public-private partnerships to another level. We've kind of figured out in the U.S. now how to do agency, NASA to U.S. industry public-private partnerships. We've done the cargo program that way. We're doing the crew program that way. NanoRacks has done a lot of great things that way. So we sort of have that figured out. What we've got to figure out in the future is, as we do things jointly as an international collaboration, how do we do global public-private partnerships? There's a couple of different models. It could be ESA to U.S. industry, or ESA to European industry, NASA to U.S. industry, and then ESA to NASA. And we could do partnerships that way. But what we envision is something that's a lot different. It's going to be U.S. industry with international industry and agency with agency, all four together as a combined global public-private partnership. If you want industry to invest in things and you see an ROI down the road, then you better show show how a U.S. company can work with a European company or a Canadian company together, maybe in a joint venture kind of opportunity to be able to realize those gains. I don't think it's going to be as stovepiped as it's been. I think it's going to be much more collaborative going forward. So where is our interest in exploration? It's everywhere. It's low Earth orbit. It's doing low Earth orbit to lunar transport. It's doing the lunar gateway. It's doing lunar landers. It's deep space transport. It's Mars. Our company has really got a broad area of interest. We're not going to do this by ourselves. We are strong believers in partnerships, both within the U.S. and international. So what we want to do is find companies that we can work with, like NanoRacks and like Astrobotic, to take advantage of capabilities they have and not go to try to do everything ourselves, but to be involved in some role in everything going forward in exploration. Thank you.
Thanks, John.
Well, good morning, everyone. Thank you very much for the opportunity to be here. My name is Dan Hendrickson. I'm with Astrobotic. We are a Pittsburgh-based lunar logistics company that is delivering uncrewed payloads from companies, governments, universities, nonprofits from around the world on our lunar delivery missions. We're partnered with a number of organizations that you see here on this title slide. We have a corporate sponsorship with DHL. So the world's largest logistics provider is sponsoring our first mission to go to the moon because we are a delivery company. Kind of a non-traditional kind of arrangement with a non-traditional space company that's really interested in getting into the forays of space and sees Astrobotic as a great entry point for that. We're also partnered internationally with Airbus DS out of Bremen. They're providing a lot of significant support to our program and directly to our lunar lander. So it's a great sort of partnership that we have with a legacy company like Airbus working with more of an emerging company like our own. We're also partnered with ULA. We're going to be flying our first mission, which I'll touch on in just a moment, on the Atlas V. We're also proudly partnered with NASA, which I'll highlight in a moment, some of the great work that we're doing under the Lunar Catalyst program, and particularly Jason's Advanced Exploration Systems program. And we also recently announced that we're partnering with Dynetics. They're going to be our propulsion integrator for our Peregrine lander, which is the vehicle you see here on the screen. So Peregrine is a product line from Astrobotic that's going to be delivering uncrewed payloads on a regular basis. In the past, planetary missions have been very boutique in nature. They've been designed for a very specific payload suite. And then following that single mission, they tend to be discarded, and they don't tend to be really reused. We're taking a kind of a radical different approach in the sense that we're building Peregrine as a product line and a design that will be used over and over again. So it's a vehicle that's very modular in nature. It can accommodate a whole variety of different payload types on a single mission. And we're really focusing on developing high reliability and low complexity. So we really want to make this as simple a spacecraft as possible, not only just for the purposes of reliability, but also to keep the process simple for our customers around the world. They appreciate the fact that the vehicle is fairly mature technically, fairly well defined, has standard interfaces for mechanical connections, electrical and software connections. And so it's really with the customer in mind that we've developed our Peregrine lunar lander. We're a very market-oriented company and very much focused on delivering for the customers. And then lastly, just to note with Peregrine, again, we're working with a lot of proven providers, a lot of very proven suppliers, and we're very excited to kind of blend the best of both worlds. Again, we're a newer company. We've been in business for 11 years, but obviously our first mission is still ahead of us, and so we're excited to work with these legacy companies to make this mission go. And again, I think this speaks to the broader theme of public-private partnerships and also even company-to-company partnerships across international borders, particularly a company like ours in Pittsburgh that's working with a company out of Germany with Airbus. So one of the points of pride for Astrobotic is that we're proud to say that we're leading the world in lunar payload delivery sales. Up to this point, we have 12 signed deals. These are actual paying customers, which I think is a pretty significant point when you're talking about something like the lunar market that's sort of on the horizon and coming. And I'm proud to say that it's not just on the horizon, it's here. it is helping fund our company directly. So it's very exciting to have actual signed contracts from a variety of different sources. So as I mentioned, we're working with companies, governments, universities. Perhaps one particular contract of note is with the Mexican Space Agency. They've signed on for a reservation of service for our program. They used that reservation to inform an RFP that they issued in country. And now the first Latin American payload will be going to the moon on our mission. And I think that's kind of emblematic of exactly the kinds of opportunities that we really want to enable as a company going forward, is to make the moon accessible to the world, allow the sophisticated payload builders around the world that don't necessarily have all of the infrastructure in country to pull off a lunar mission themselves, but they can work with a US company like us to get there at a very low cost. In fact, we offer 1.2 million per kilogram to the lunar surface, which is, historically speaking, a very low price for getting payloads to the lunar surface. We have over 130 deals in our sales pipeline. This is actual conversations that we're having with customers right now. It's not a theoretical market projection or a study going forward. And that's valued at over $2 billion right now. So again, our first mission is ahead of us. It's going to be toward the tail end of 2020. Despite that fact, we already have paying customers that are signed on from a number of different sources globally, which really shows, I think, the pent-up demand that's existed for getting to the moon. And it really bodes well going forward for partnerships like the ones that we're talking about up here, particularly when it comes to the global exploration roadmap. So one of the difference makers that I think has enabled a lot of those sales has been our steadfast commitment toward technical development of our lander. We've got 11 years of lander development work. We've invested significant dollars in our own company toward the development of our Peregrine lander. And again, speaking toward partnerships, the NASA Lunar Catalyst partnership has been spectacular. It's been out of the Advanced Exploration Systems Office, out of Jason's leadership, and it's really been a great partnership because it's allowed us as a company to get a lot of experience and a lot of wisdom directly from NASA engineers working shoulder to shoulder with our teams. There's just no replacement for NASA expertise. I'd like to think that NASA also gets something out of it, and that is an understanding of how we do business as a company, and hopefully helps inform how NASA does business themselves as an agency. But also, I think that's what's really helped enable some of the lunar plans that have been announced, because they have a very close, intimate understanding of how we do business. They understand our technical solutions very closely, and I think that's what's helped enable now the Commercial Lunar Payload Services program, better known maybe as CLPS, that's been announced, and we hope to be a CLPS provider for NASA. And I think, again, it's because we've been working well together over the last 3 years on a daily basis, frankly, and so it's really provided a lot of insight into how we do business. We're also proud to say that we have 26 NASA contracts to date, so we're very proud of our ability to deliver for NASA on a regular basis. And our Peregrine lunar lander overall is at a PDR level. We don't take that preliminary design review status casually, which is, I think, emblematic of the fact that we actually had Airbus send an independent review team to our PDR, and they independently judged it. So we had folks from outside of Bremen, from another part of the company, come and evaluate our technical solution, and they were comfortable and confident enough to say that Airbus certifies that it is at a PDR level, which is not a low bar to meet, to say the least. So maybe just to speak a little bit about the deep space architecture and the global exploration roadmap, Astrobotic is really excited about where the space community is going beyond Earth orbit. We have SLS, we have Orion, the Gateway, and I think all of those architecture elements coming from NASA and from the community of space agencies around the world are especially well aligned to take advantage of what's already happening in the commercial market with services like the Peregrine lunar lander. So you can imagine that all of these elements kind of are able to feed off of each other and leverage the capabilities, whether it's from the private sector side with Peregrine or if it's from the public sector side with Gateway. Gateway is a really exciting capability, and I think it works really well with small lander services, starting out hopefully with the CLPS program in the years to come. And I think there's a number of really unique applications that Gateway enables and works really well with Peregrine and services like what Peregrine offers. So for example, you could have astronauts working at the Gateway, carrying out telerobotics activities with small lander services and perhaps rovers that are being deployed off of vehicles like Peregrine. You reduce the latency issues by having that telerobotic work happening at the Gateway. There's also opportunities to perhaps do sample return. You could have Peregrine bring the first samples back from the moon for a number of decades from the US side, bring them up to the gateway, and then you reduce the cost for getting those samples and on a more regular basis. So again, because Peregrine is a smaller lander, you can have it deployed all over the lunar surface and gather really a diversity of samples, which the science and exploration community has really been desiring for a number of years now since the Apollo program. And then also Gateway can serve a number of other practical applications working in concert with Peregrine on things like comm relays. The Peregrine lander is designed as a product line to go to really any destination on the surface, but particularly on the far side, it's somewhat challenging to do that just with a lander alone. You really need an asset that can do communication relays, and the Gateway can serve that purpose as well. And then maybe even kind of thinking a little bit further down the road, once you've done maybe the first prospecting missions at the surface to determine what kind of water ice content exists on the moon, you could even imagine a scenario in which, say, Peregrine gathers the first volatiles of lunar water ice, brings them up to the Gateway, and demonstrates the first transfer in space of volatiles. Again, that's not necessarily going to happen next year, but this really kind of creates the infrastructure needed, these architectures, creates the infrastructure needed to enable these kinds of activities that someday could really change the equation when it comes to doing operations beyond Earth orbit and utilizing the resources that exist on the moon. So just at large, I think Astrobotic is incredibly excited about where NASA and other international space agencies are going, and we're really ready to serve. It's an exciting time, and we stand on the shoulders of SNC and NanoRacks, who've done so much great work and have demonstrated models for working company to company and company to space agency, and we want to leverage that now for the cislunar environment. Thank you very much.
Thanks, Dan. So hopefully what you've heard is a broad perspective of the very complex environment that we're living in as far as exploration. Starting from a space agency perspective and our changes in the space agency that we're all actually implementing today, the knowledge that we're gaining from testing on the International Space Station that's critical for exploration, the whole how do you maximize shots on goal on experimentation of business concepts and ideas? We've seen that in plethora, a lot of good ideas, some bad as well. But then as a space agency, be able to step back and say, as Jeff noted, it's okay to fail safe and let the companies make those marks. All those are helping us teach how we're going to do exploration in the future. And the entire global industrial base is significantly changing, as you hear from our industry panelist here. So with that, I'm going to turn over to the first question, actually from the app. From the back of the room, Katie, if you could read off the first one.
Okay, we have a few good questions here from the audience. A couple people are interested in how traditional agency-to-agency cooperation model that is currently used between the ISS partners might have to change when you start to rely on industry investments and commercialization.
Yes, I'll repeat it for the folks up here. I mean, the basic crux of the question is, how does the agency-to-agency partnership model potentially need to adapt to enable the actual landscape that you heard described by our industry panelists of that? So if you guys want to take a crack at that?
Well, as I see it, obviously in the IGA for ISS, it's between governments effectively. The relationship, and to my knowledge, doesn't really cover the commercial angle very well currently. And so I think regarding that, what we've been able to do up to this point is essentially apply good judgment and the cooperation of all of the partners to be able to support this evolving sort of movement, if you will, commercial movement into space. We look ahead and we look at Gateway and then potentially another cooperation of sorts. Potentially, and again, we don't know what the future will bring, but it could be a spider web of agreements under a broad sort of vision or objective statement where you have relationships with multiple entities. It could be government to commercial, and then that relationship is reflected between government to government. It's hard to say. I think this is where I think a lot of new creativity will be required on how we want to do that. And maybe one way is to not be too rigid in how it's identified, because when you look at the IGA, it doesn't address commercial in it today. We've found a way to work through it, so maybe there's a way to work through these things with some framework of relationships formally documented, but with the understanding that a lot of other relationships can exist in a less rigid format. So that would be my first take on it, and I think there's going to be a lot of work that we've done a lot of technical work and done a lot of commercial business work on that part of the story.
For me, the Magna Carta of space is the IGA. And it's a founding document. It's a masterful document. It has wonderful provisions as a waiver of third-party liability, how it handles technology transfer. It's been proven to have worked, which is the most important thing among, how many nations as part of the International Space Station. So, as you say, it doesn't include commercial. So my hope, though, is as we go to deep space, we do use the IGA as a founding document. I worry it would take us 20 years to replicate something along those lines. And if we regard it as more a Magna Carta, a founding document, I think the future, allowing more commercial participation, also funds, just funds to exchange between agencies, agency to commercial, to allow competition. There's no reason why space cannot be like other marketplaces where a private sector in one country can bid for space agency work in another country. It's still an extraordinarily protectionist industry. And so I think changes like that would be healthy for all of us, but using the IGA as a starting document.
Yeah, let me touch on that a little bit, because one of the things that I'm really engaged in right now is looking at different kinds of business models and engaging with international companies in what we call global public-private partnerships. And where it gets a little bit confusing is it's one thing where the government owns a resource like the International Space Station, and they may pay for some services and they pay for some equipment, but it's really a government-owned type thing. What the government's trying to move to now is contractor-owned, operated, and government just as a customer of that, of a service. So it's really going to be a very different model. Let's say you put up a gateway or something in space, and you expect the companies to invest in that. And the US builds a module, and a company invests in that and has some ownership of that module. And Europe provides a module, and their companies invest in that, and they own part of the module. But now you stick them together, and they operate as one unit. And how do the companies see a return on investment on an individual module that's part of a bigger thing? It's going to be very difficult. So what we're looking at is, could we work with the international companies that are supporting ESA and JAXA and CSA and form joint ventures of our companies where together we jointly own and operate that service? And NASA funding can come to the US companies that are part of the joint venture because NASA wants to spend its money in the US. ESA can spend its money with European companies, as they like to do, but eventually there is a joint venture of the partners, and the partnership runs and operates the service in space. So it could be a contractor-owned, contractor-operated type of service, but there's a way for the companies to see mutual investment and a mutual return, even if they're only really building only parts of the entire thing. So I think that's going to be really critical as we go forward, just as much as the technology development is how do you develop on the business side and develop business partnerships that are going to be viable in the future.
Well, thanks. So, Katie, do you have another question from the app?
Yes. What is the current development status of the mid-sized lunar lander depicted in the NASA Exploration First roadmap? I believe that's for you, Jason.
Yeah, this one's for me. So NASA has a couple different ways we're engaging the lunar lander communities and the overall efforts of building a lunar lander capability. Dan referred to a couple different ways. We've had for historically technology investment contracts and partnerships to do technology risk reduction. We've had competitively awarded no exchange of funds space act agreements as well as part of our Lunar Catalyst effort with Dan and Dan's company and actually 2 others. We just extended those partnerships by 2 more years. And then recently now, led by our Science Mission Directorate, we're now proceeding to buying landed services as part of the Commercial Lunar Payload Services, or CLPS contract. That is, the draft has been released and we're starting to progress towards the actual acquisition of landed services. Those landed services we expect to be on the smaller scale at the beginning and then building as the market demand justifies into larger capabilities. In parallel with that, as part of the overall activities we have going on, we want to build the opportunity to build human-class landing capabilities. So you see the mid-sized lander and you see the landing in 2022 and another landing in 2024. The intent behind those is a stepping stone towards a human class, with the first ones on the scale of 500 kilograms of payload landed mass on the surface. And the second one could be as large as several thousand kilograms, up to the 5,000 to 6,000 kilograms of landed mass, which starts to get you at the performance that you need for a human ascent vehicle. So the current step that we're at, we actually have released the synopsis for that actual engagement for those medium and large landed services. We laid out in the synopsis investments towards the first landing and also risk reduction activities towards the second landing as well. And we'll engage with industry on studies of short duration, especially for the first one, proceeding to actual flight hardware and demonstration of that 2022 lander. And then we'll spend a little bit more time advancing cryogenic propulsion systems and the like in order to get and build to the 2024 class. But the synopsis is out and we're working through the release of the actual procurement in the coming month.
All right, for our next question, we heard from Astrobotic about their efforts with Latin America. Which has to be the next step to consolidate a space agency in Latin America? And are you considering Latin America as a good partner to the space sector?
Can you repeat the?
Can you repeat the question, Katie? We missed the first part of it.
Oh, okay. Which has to be the next step to consolidate a space agency in Latin America? And are you considering Latin America as a good partner to the space sector?
Yeah, you can. I mean, I don't think you consolidate across Latin American countries. That's probably that would be an interesting assumption for policy folks to take a look at. As far as our overall engagement strategy for Gateway and everything else, we obviously have very active conversations with every one of our international partners for ISS. But the way we are structuring it, and the way Jeff and John talked about it, and Pierre, we're structuring the ability to on-ramp additional new international partners throughout the entire implementation of our exploration strategy. So that's pretty critical. But maybe, Dan, since you actually have customers in Latin America, I don't know if you want to add to that, or?
I don't think I'd add too much, just to say that we're excited to work with all regions of the world. I think one of our sort of slogans is to make the moon accessible to the world. So we're very interested in actually engaging in a number of Latin American agencies right now about potential cooperation.
Okay.
So is the knowledge from all of your efforts shared between space agencies and to the public?
Is knowledge exchanged between all the agencies anti-republic? Is that the?
And to the public.
And to the public?
The person who asked that question in the room, if you could give a little more explanation, that might help us for that.
I think it means, is it public in the public domain, the information?
The exchange of actual lessons learned. So many of our lessons learned are shared at conferences like this, and many other technical conferences by every technical society that's out there. So I mean, a lot of our lessons learned on station, everything from research to actually our exploration technology, risk reduction activities, a lot of those are published as technical journals and such. So there's a vast range of public information shared out there. What we also see now is also the emergence of commercial activities, where some of the commercial outcomes are part of what they're wanting to test. So in the case of commercial opportunities, I believe that's probably between that entity and the service provider that is enabling them to occur. But the side of the space agency side, we do tend to share that widely and openly across many different folks.
How can industry facilitate the advancement of the global exploration roadmap for space agencies, starting from the ISS?
Yeah, so interesting. This kind of plays on the questions you guys are bringing up. So how does industry think about and interpret a global exploration roadmap, and how would industry help promote that themselves? So John, you kind of talked about that with your global public-private partnerships.
So the one thing about public-private partnerships is they have to make sense from both parties. The public part, which is going to be the space agencies, they have certain goals that they want to do in space, and not all of those goals will have commercial fallout. And the commercial company obviously is looking at making a return on investment. So they're looking at what are the things that NASA is doing, for example, that I think I can make a commercial business at and see a return. So we have this great partnership where they get what they want and we get what we want. The place that public-private partnerships don't work very well is that one of the parties has much different goals than the other party. It's when, if NASA were to put out an opportunity, for example, and say, we have a public-private partnership in this area, but all the commercial companies look at what NASA wants to do and say, well, that's great, but there's no commercial market for that. You want to go to Jupiter and look at whether it has some sort of resource. Well, that's great, but we don't have any customers that want to know whether Jupiter has any resources. But they want investment from the companies. And on the other side, if the company is wanting to do something that really doesn't move forward with what NASA's goals are, then you have a very unbalanced kind of relationship. So that's one of the key things in forming these public-private partnerships, is trying to balance the commercial company's objectives with what NASA's objectives are. And that's not always easy. There's some things going on that are public-private partnerships that we don't really believe are great models for that, because we don't see a great return in that area. But NASA's interested because it reduces their costs, so they have a motivation to try to make it happen. So there really is a negotiation that we're still going forward with back and forth, I think.
Yeah, maybe I would just add, I mean, talking about public-private partnerships, I mean, the private is looking for revenue and they're looking for profit, and the public is looking to enable that in a fair and partisan and non-partisan manner. And so when we look at I think what we see happening in the low Earth orbit now, we've seen this commercial marketplace starting to gel, and it's just started, and it's been going on for a few years. And so really, as I see it, and it's just my personal opinion, but as I see it, low Earth orbit is where that market will really develop in the next, say, 10, 15 years. I mean, its proximity is close. There's already commercial presence in the environment. When you look at the gateway, that's a lot more riskier for companies, I would say. There may be some public-private partnerships. I wouldn't see them in the early days. I see them as the gateway formula, it starts establishing itself, and then the vision of the governments moves forward, and then the companies will see where the opportunities are and identify them. They might be right at the beginning, but more than likely, I mean, when you look at it, we hear so much about mining on the moon and resource utilization and all that. That's potentially where the companies will see potential revenue. And so again, we can't just assume that because it's happened in ISS LEO, it's going to happen right away on day one in Gateway. It's an evolution, I think, so just a comment there.
Maybe just to add as a practical example, at the moon, for example. We designed Peregrine to be modular in nature because we recognize that different agencies and different customers are going to have different interests on the lunar surface. So one of the things that we have tried to really focus on as a company is not presupposing what the future on the surface of the moon is definitely going to be, and then building that one solution for that one demand. So for example, we as a company could have said maybe helium-3 or ISRU of water ice or exploration instruments, or one of those things is going to be the future on the moon, and then we're going to go all in on that. We decided to really focus on just modular payload delivery to start. So show that it's possible to get to the lunar surface at the price point that we're talking about, and allow each agency to then take advantage of it with each of the interests that they bring to the table to try to then sort of organically grow it. And again, try to be more market responsive rather than us presupposing what the agencies want to do in those partnerships around the world.
No, that's kind of a good segue, Dan. I mean, to kind of wrap up, it really hits me kind of on what you're saying, not predisposing what your own market is. I think one of the things we've learned on the agency side is not predisposing what your guys' market opportunities are either. It's been really critical. So I'll wrap it up with it. If you go back to my original kind of kickoff, we have this explore and develop dichotomy that's out there, and they must coexist. And how do we go out and do the exploration, use ISS as a platform of discovery for scientific technology advancements, market opportunities, all that is a platform of discovery of ISS, and then leverage those knowledge gains into what we want to do for exploration. But then always be looking back at what is the next development thing that wants to do, so that when we go and execute an exploration mission, execute it in such a way that we don't close the door to market opportunities for industry, because there's no way we can predict where that will be even a couple years from now, never mind 10 years from now when the gateway assembly is complete. So I want to give a big round of applause for the panel today. Thank you guys for your insights. Really appreciate it.